So I know we have more factoring, and we're going to look at the most common type of factoring that we ever do, greatest common factor. This greatest common factor is going to be a little bit different, and it's going to be similar to stuff that we saw early on in the last chapter. So I want you to look at these first two problems. It says let's compare the factoring of the next two problems. These are exactly like the first two problems on the homework. So even though I'm not here, I want you to look at these two when you do the homework tonight, and just the first two. It might be more than just the first two, but definitely the first two. So the first type of factoring we ever learn is greatest common factor. And between 3x squared and negative 2xy, they both have an x in common. If I pull an x out of 3x squared, I should just get 3x. And if I pull an x out of 2xy, I should get 2y. Now, moving on to this problem, number 2, this is very similar. Very similar. It's just that what this and this have both in common is a 2x plus 1. And I need to see the 2x plus 1 as a complete group. I need to see that completely together. Sorry, I should highlight those the same color. But they're together. They're one group. I kind of need to see this as like one complete entity that they both have in common instead of separate numbers. And I'm going to factor that 2x plus y out to get a 2x plus y in parentheses. And when I pull it out, I get 3x minus 2y. We've seen that before, but I want you to compare these two. On the left side, we pulled out an x, and I got a single x, and on the right side, I pulled out a 2x plus 1. These can't factor any further, so that one's done. Now, move on to numbers 3 and 4. We're going to compare the factoring of the next two problems, and this might help you with problems 4 and 5 on the homework. So these are not completely identical, but they are similar. This first one is a classic difference of two squares. If I factor it, it factors into something minus and something plus, and I got x and 5 and 5, and that one's done. That's pretty easy. But if I factor the next one, I want you to see this also as a difference of squares. This is also a difference of two squares. And it follows that pattern because it is something squared minus something squared. Really what this is this is x minus 4, squared minus 5 squared. So this is definitely a difference of two perfect squares. So now what I get is x, well, when I pull this apart, I need to pull out something with a plus and something with a minus. And I'm going to do the last spot now. I'm going to put in the 5s. So what goes in the first spot? Well, I'm going to expand this a little bit. And what goes in the first spot is this x minus 4. It was an x minus 4 squared, so what I need to do is I need to put an x minus 4 here and an x minus 4 here. And if I were to multiply these two back together, I would get an x minus 4 squared. My outers and inners would cancel each other, and my lasts would be minus 25. Now this can simplify further. I can drop the parentheses in x minus 4 plus 5 and x minus 4 minus 5, and that can simplify even more. This becomes x plus 1. This becomes x minus 9. So this step here looks a lot like this step here, but then notice how it could go even further to a final answer of this. Moving on, this next problem has two strategies. Tomorrow, or the next day, we're going to do the difference of squares strategy, but the directions here just say multiply and factor. This is going to help you with problem 6 on the homework. So what I'm going to do is I'm going to square this one. I'm going to do that by multiplying it by itself. Now in the last chapter we practiced squaring as x squared minus 2 times 7x, so that would be 14x, plus 49, minus, and then I'm going to put this next one in parentheses because I want to square that next, and then distribute the negative later. This would be x squared. This would be 5x and another 5x, so plus 10x, and then last is plus 25. Now, I want to take this part here where we were foiling that and move this over. If you need to multiply it and write it twice by itself and then actually do x squared minus 7x minus 7x plus 49 to get to here, please do that. And if you need to do x plus 5 times x plus 5 equals x squared plus 5x plus 25 to get to here, do that. Okay, we're going to distribute the negative as the next step, so plus 49 minus x squared minus 10x minus 25. If I add like terms, my x squareds cancel, and I get negative 24x, and my 49 and 25 add to become a positive 24. And since the problem says to factor, I'm going to take out a negative 24, and that's going to give me x minus 1. So that's the fully factored form. Now, we're going to try a few problems. So let's look at 6. Something squared minus something squared. This is difference of two squares. So I'm going to take a plus and a minus. And in the last spot, it's going to go a 1 and 1. And in the first spot is going to take, I'm going to take this square and I'm going to make it not be to the second power. But I'm going to keep the y squared minus 24 in a group. So let me write this a little bit better. This is y squared minus 24, and this is y squared minus 24. I'm not touching the y squared minus 24 yet. I'm not doing that because it was y to the, oh my bad, this is y to the fourth minus 24. You guys are probably wondering why I'm doing that. But I'm not touching it. It's going to stay exactly the same as what I see right here. Y squared minus 24, this is y squared minus 24, this is y squared minus 24. The reason is because it was to the second power. Now it's to the first power. And it is to the first power because if I multiply these back out, I need to get y to the fourth minus 24 squared. Now I'm going to drop these parentheses, y to the fourth minus 24 plus 1, and y to the fourth minus 24 minus 1. So then I get y to the fourth minus 23 and y to the fourth minus 25. Well, this second one can go further because that's a difference of squares. That'd be y to the fourth, or sorry, y to the second minus 5 and y to the second plus 5. And we can't take any of those down anymore because they're not differences of squares. 5 is not a square. And the y to the fourth minus 23 also has to continue down, and that one's done because it's not a difference of squares. So, number 7, this is going to be, is this a difference of squares? Well, first we can take out a greatest common factor. And between this and this, well, I can look at the 100 and the 36, and I know I can take out at least a 2, actually a 4. So I can take out a 4 from that. But I can also take out, this is x minus 1 squared, and this is x minus 1. So I can take out an x minus 1, because this second one only has one first power. And when I pull that out, I take the 4 out of the 100, and I get 25. And I take the x minus 1 out of the x minus 1 squared, and I just get an x minus 1 to the first power. So then I'm going to take this minus. And then when I take the 4 out of the 36, I get 9. And when I take the x minus 1 out, I just get 1. So that one's done so far. We're going to now simplify this part. So I got 4 times x minus 1 times 25x minus 25 minus 9. And that leaves me with 4 times x minus 1 times 25x minus 34. And I'm going to check to see if there's anything that goes into 25 and 34. No. So this one is done. Lastly, if I look at this and this, I can take out a u cubed minus 4. And when I take it out of here, this first one, it leaves behind a 1. When I take it out of the second one, it leaves behind an 8x. That was pretty quick. So that's the gist of it. Good luck.